Okay, my name's Tristan Larson, and I'm from the ARC here at IIT. I'm a math tutor, and today I'm going to be going through a workshop on integration by parts. Okay, integration by parts is a problem-solving technique for uh, different kinds of integrals. It's particularly useful for solving integrands involving products of algebraic and transcendental functions. What is a transcendental function, you might ask? It's a function. The definition of a transcendental function is a function that does not satisfy a polynomial equation whose coefficients are themselves polynomials. And basically what this means is it's a nonlinear equation like e to the x, any exponential function, ln of x, the natural log of x, or the regular log of x, and trigonometric functions like sine of x, cosine of x, tangent x, any variation of those. The general theorem for integration by parts is if you have u and v, they're two different functions in the integral, within the integral, and they have continuous derivatives. Then you have u dv equals uv minus the integral of v du. This is it's just a general formula. A good way to remember it is the integral you're looking for is equal to ultraviolet voodoo. It's just a little mnemonic device. You've got uv, that's the ultraviolet, and the v du, that's the voodoo. Okay, so this is the basics behind integration by. Okay, let's go through our first example. We've got the integral of secant cubed x. All right, so the first step is to pick our u and our dv. And so secant cubed of x can be split up into secant of x and secant squared of x. So let's do that first. So we've got secant of x and secant squared of x dx. Okay, now we'll pick our u to be secant of x and our dv to be secant squared of x dx. It's important to remember to put the dx on the end because you can't integrate something unless it's in terms of something. In this case, it's in terms of x. So we'll plug this. Well, we have to find du because that's part of our general equation. U dv equals uv minus v du. So our du, the integral of secant x, is tangent of x dx. And the integral of our dv, v, is equal to tangent of x. That's these are just two they're just two rules. I could go through the proofs, but it would take forever. So now we plug this into our ultraviolet voodoo equation, and we get secant cubed of x dx, our original integral, is equal to u dv. So we got, or uv rather, secant x tangent x minus the integral of v du, tangent x. Sorry, I think I screwed this up a little bit. V du. So tangent x, tangent squared x dx. Oh, I'm sorry. Du. This is equal to secant x tangent x. That was my mistake. Du, in this case, it's secant x times tangent x dx. That was just a error on my part. So this is going to be equal to secant x tangent squared x. Okay? So